Let's begin with how requirements may be found. Requirements may be found because somebody who's expert in a domain or is um, reasonably familiar with a domain um, realizes that a particular need needs to be filled. In other words, somebody might have a creative idea or a creative understanding of a need and wants a software system to be then built to fulfill that need. But if you want to do this systematically, there are a few techniques that companies will offer, will follow rather. So one typical technique is a company will have, an organization will have um, a prototypical user in mind or a set of users in mind, and they know that these users have a problem. They know that they are either being inefficient in their work or there is a possibility of automation. They know this at a high level. So then they identify these users. They typically find prototypical users. So users who are more likely to be typical than users who might be not good examples of the kind of users they may be looking for. And then they interview them. So they interview them at length. We have seen that you have this problem. Um, can you explain in some detail the nature of the problem? What is it that you're doing when in order to what task are you doing? What are the difficulties you're having? Um, do you have any thoughts of how a software system might help and so on? So this is just basic interviewing. In many cases, the users have a set, nowadays anyway, users have a set of software systems that they use to solve a problem. So and new requirements really come about because there are gaps in the software system. Either the system has certain functions that are not, the user does certain functions that are not automated, so have to be done manually, or the user has to keep in his mind the process that needs to be followed, rather than the system helping the user in doing that process, things like that. A second systematic way is to examine value chain activities. So this is higher level than interviewing users. So you take a company might look at its value chain activities, try to understand where it wants to excel, and then examine these value chain activities in detail to try and understand where computing or information technology or software might help. And after these broad areas are identified, then of course you go back to identifying prototypical users and figuring out how people work and doing all that detailed study. But at a first level, organizations will find that there is a gap by examining the value chain. A third systematic way is something known as an ethnographic study. And we've included a paper on an ethnographic study in your reading material. So an ethnographic study is typically a detailed study, an embedded study, where the observer, almost um, embeds himself or herself in the user's environment, home or workplace and so on, and observes how that person works and what things he or she has to do to work around the difficulties they might be having. You might have heard of a company named Intuit that makes Quicken software, also makes TurboTax, now has TurboTax on the web, also makes small business software named QuickBooks. But anyway, Intuit came up with its ideas for its software products, initially at any rate, by doing deep ethnographic studies that they called Follow Me Homes. So they had their analysts, well, they had their people. In fact, the owner and now president of Intuit, he basically sat with a collection of families to understand how they managed money. And based on those observations, he came up with the first concept for his accounting product, Quicken version 1. Before that, accounting products were not targeted towards families. They were double entry accounting systems targeted at accountants that were then repackaged to sell for doing account management at home. But this was not how people did accounting, and which was why these accounting packages hadn't taken hold within homes. What Intuit found out was that people who do accounting at home basically center it around their checkbook and put everything in their checkbook. And Quicken version 1 was essentially completely centered around the checkbook. Of course, it isn't now. It has evolved to the point where it's a very, very sophisticated accounting system. But the first Quicken was really checkbook centered, and its customers sort of grew along with it. So version 2 added a little bit more complexity and so on and so forth, but it wasn't as if people were buying that complexity fully from the beginning. They were starting with a paradigm they understood, and then the system sort of evolved and provided more and more functionality. Embedded field study is also a version of an ethnographic study. Usually, an embedded field study refers to studies that are done within a societal ecosystem. So somebody might sit in a village, in a fishing village, say in India, and observe how people work. Longitudinal research is research over time. So ethnographic studies are typically longitudinal studies in the sense that they observe that situation not for a short instance in time, but continuously over time, say 3 months, 6 months, a year, something like that. And in all of these, typically, once you have an idea of what needs to be done, the requirements gathering process ends up in these in-depth interviews, the kind I talked about earlier. As you conduct these studies, ethnographic studies, value chain activity, examination, embedded field studies, all of these, the question now becomes, how do you capture these requirements? How do you formally document these requirements as a means of kicking off the rest of the software development process, which is the analysis of these requirements, the design of the system, the development of the system, and so on. So structured processes and agile processes capture these requirements in different ways. Okay? And what we will talk about next is how you capture these requirements using in a typical structured methodology or process. Here is a list of work products for a structured requirements gathering process. In the next set of slides, we will go through each work product and explain each one. The first requirements work product we'll look at is something known as a problem statement. The idea behind the problem statement is to capture the problem that the software system is going to be solved. In other words, it's focused on the need, not on the solution. It might include things like text description of the problem to be solved. It might capture business goals. It might capture business objectives. It is typically written with the customer before the software system is developed. The whole idea is to capture the problem and identify what the solution is expected to deliver in terms of results. It's not a specification of the solution. This is not a structured document. It's typically a document created in free format text document. You might have section headings and so on just to separate out the document's components and make it more readable. But that's essentially what it is. Here is an example of a problem statement, or actually part of a problem statement from a project I did with a local law firm 2 summers ago. The law firm was an interesting law firm in the sense that it was not a traditional law firm that did, for example, litigations in court or prepared briefs, legal briefs for corporations and so on. It was a high volume law firm, and it specialized in the processing of foreclosures. There were very few lawyers in the firm. There were just about 4 or 5 lawyers, and most of the work was done by people who did not have a law degree, did not even have, were not even paralegals or anything like that. It was just people who were trained in administrative skills and were trained in the foreclosure process by the law firm as part of their employee training. Okay, so it was a high volume law firm, and they were primarily measured on how accurately and in what volume, how quickly they did the work of processing foreclosures. This kind of organization that is measured on efficiency and throughput and accuracy is a prime candidate for a software system. And they wanted to build a software system, an automated workflow system that guided the user, their non-legal non-legally trained employees in following the process of processing a foreclosure. The next work product is a work product known as a business case. This business case is a justification of the expense of doing the project. So note that again. It's a justification for the expense that in terms of money, effort, people time, and so on, that will go into the project. And it is, or it should be structured in two parts, a cost section and a benefit section. And in the cost section, you have ballpark estimates of how much money will be spent, how many hours will be expended, and so on. And in the benefit section, you have the value that will be generated by this system. Now, at this time in the life cycle of the product, it is unlikely that people will have a clear idea of either the cost or a specific idea of the value. So the idea here is to capture it at a high level. And as the project evolves and you understand better what to build and what that system will do for you, you refine both the cost parts of it as well as the benefits part of it. Okay, note that the cost parts may be in dollars and cents, money or effort. The benefit part ideally should be quantified as much as the cost part is quantified, but might be also intangible in terms of social benefit, employee morale, things like that. But most organizations will try to make the extra effort of converting these indirect benefits into dollar values. But regardless, keep in mind that both the cost and the benefit might not be completely quantifiable, might include soft elements. Here is an example of a business case, once again from the same project that I did 2 summers ago with the law firm. Look how it has been broken up into 2 sections, a cost section and a benefit section. Let's take a look at the cost section. It's an estimated cost, and we've estimated the cost as $1 million. We'll look at better ways of estimating cost in a later module. In this particular case, because it was early in the life cycle of the product, the estimated cost was essentially derived based on the resources that would be committed to the project. So the owner of the company essentially asked me, how much do you think building a system like this will cost? And I gave him an answer something like, well, you'll need a project manager, you'll need a DBA, you'll need probably 3 software developers, you'll need 1 software architect. These folks will have to be full-time for the first year, so you have 5 people full-time. Each of them would probably be costing, say, $100,000 a year. So that would make it $500,000. Assume additional time from the potential users of the system to collect requirements and so on. Throw in equipment costs. You'll need a development environment. You'll need a test environment. You'll need a deployment environment. You'll need software licenses and things like that. And you can come up with an estimated and we came up with an estimated cost. Once again, primarily based on staffing size and the estimated duration of 1 year of about $1 million. Now, this might be a very high-level estimate, but at least it gave this owner, who was not an IT savvy person, a computing savvy person, gave him the understanding that this was likely to be an expensive project. Not everybody can throw $1 million out on a project, and that he should be expecting at least $1 million worth of return. Looking at the benefit side of the equation, you will see how we calculated that. We said having a software system in place will reduce training costs because training doesn't have to be sitting with the person for a month and watching and explaining to them in detail how they should do the work. The system would guide them, and they would only be need to train in the use of the system, not in how the process worked. And we estimated that we could save about 1% month of training per employee, and that there was a turnover rate. Basically, they hired 10 new employees every year. So combining the two together, we came up with a benefit in terms of reduction in training costs to be about $100,000 in that first year. Now, this law firm, if they made mistakes in the foreclosure process, became subject to penalties. And if they had delays in their foreclosure in doing their process, they were subject to penalties. And the feeling was that having such a system, because it would keep the people on track and notify them of deadlines and help them do the work faster and so on and so forth, that they could save about $250,000 in penalties every year. These penalties being caused by errors or delays in the processing. It was also estimated that about 25% of a person's time, of a trained person's time, was spent in inefficient tasks, basically doing manual things to cover up for what their current system did not do. And the thinking was, if we were able to save 25% of everybody's time doing that they spent on non-essential items, they could do 25% more work, which meant that the law firm could process 250 cases as opposed to 200 cases every year. So adding all that up meant that we could see a dollar return for about $700,000 in the first year of operation itself. So the thinking was, hey, if we build this system and spend $1 million, then within a year we'll have made back most of the money, and in 2 years we would have certainly made back all of the money. But there was also a soft advantage, a non-quantifiable advantage, which was winning the foreclosure business by a law firm is a highly competitive business. In other words, in order to become a preferred foreclosure processor for, say, countrywide home loans, a law firm like MDK would have to show that they were credible, that they had the experience to do this, had prior successes, and so on. Well, now they could say something more. They could say, we have this proprietary software system that we built that is customized to the foreclosure process that allows us to do the work much faster and more accurately than the other law firms that are competing for your business along with us. All those other law firms only have paper processes. You know that they're error prone. You know they are slow. We can do better. We can do things faster because we have this computer system. And the thinking was that this would be a tangible asset that they could use to win new business. A very useful work product for collecting requirements is what is known as a storyboard. Now, a storyboard can be, and a storyboard is precisely that. It's a narrative. It's a story, perhaps with pictures, perhaps shown through PowerPoint, perhaps simply narrated. A speaker comes up and tells a story using a PowerPoint or a slideshow to illustrate his or her points. The idea, a storyboard can be used to capture how an organization typically currently works. It can be used to capture how a set of users might interact with the system, what the vision is. It's a very useful way of getting started. So, rather than thinking I have to create all these different documents, creating a storyboard often happens very naturally when you interact with the users. It's a good work product to create, just to get things started. Typically, so you could create a storyboard from an ethnographic study. You could create it from an in-depth interview. It's just a story that describes either how the current system works and what the problems are and so on, or it's a description of how the new system might work and how it might interact with the users. Keep in mind that it's a narrative. It is a story, and it's an informal way of capturing requirements from which the other more structured, or rather more systematic work products will be created. A work product that you will hear a lot about is a work product known as a use case model. And it consists of three components. The first component is a description of the actors that will be using the system, the actors in the environment that will be using the system. And these actors are typically human actors, or they could also be system actors, which are external systems that your system has to interact with. The second component of a use case model are use cases. And use cases are basically visible behavior of the system captured in a intelligent way. Okay? Packaged into collections that make sense. Okay, user takes money from ATM, user checks balance at an ATM, things like that. Okay, so each of these would be separate use cases. The third component of a use case model is what is known as a use case diagram, and this use case diagram captures the context of the system. So it shows the system and who it interacts with. It's a model that shows the once again the context of the system in a compact manner. Most structured processes, in fact, all structured processes, use use cases as a starting point. Use cases, drive all other activity, starting with analysis, and they also end up closing the loop with the acceptance tests that users will do in order to accept or validate the system or actually to sign off on the system. Here is an example of the actors, once again from the system that I helped develop 2 years ago for this law firm. Note how the actors have been structured in almost an inheritance hierarchy. So the top level of the hierarchy is an actor. One level down is an employee of the firm. The third level down and a subclass of employee is the user of the software system. So the idea here was not all employees of the firm would be using this system that was being developed. And underneath that, there were the four prototypical users of the system. A user that played the role of what was known as an intake processor, a title administrator, a title processor, an attorney. And finally, there were users of the system outside the firm, and these were consultants. And one such prototypical consultant would be a title examiner. So once again, the actor hierarchy defines the prototypical users in a system. These users are structured in an inheritance hierarchy, starting with the most general sets of users and trying to be more and more specific. Keep in mind that users might be both external to an organization as well as internal to an organization. Okay? And here are some example use cases, once again, from the system that I helped develop. So here were a set of use cases performed by an actor named the intake processor. This actor was assigned to a department named intake, and it made sense to capture that. There were three standard use cases that this actor around which this actor would interact with the system. So there was a use case where the intake processor would claim the case from the client system. So this was this law firm claiming a foreclosure case from a customer, such as Countrywide mortgages, Countrywide home loans. The second use case was the intake processor would assign an attorney to oversee this case. And the third normal use case was this intake processor assigning a title examiner to do the title evaluation for this case. There were also 4 exceptional use cases that this actor, this intake processor, would interact with the system around. And I found it useful to split the normal and exceptional use cases. The normal use cases would be the use cases that this actor would use the system for most of the time, but there were a few use cases that were sort of exceptions to the rule that were needed, and whose features were needed rarely, but were important. And the reason for characterizing them and splitting them was essentially to help in prioritization. On this example use case diagram, you can see two actors. One is a human actor, the intake processor, and the other is a system actor, which is the client system. As I said before, the client systems are the systems from Countrywide Home Loans and so on, from which the system that we're building is supposed to pull foreclosure cases from. And the human actor is going to be interacting with the use cases shown that are connected that he's connected to with an arrow. And further, that one major use case translates to a collection of smaller use cases. So once again, this use case diagram shows the context of the system. And one other thing, the system is what's inside that square box. So you see all the use cases within that system. This is what the system is supposed to implement. And then you see the intake processor interacting with those use cases, and you see these use cases interacting with the client system. And then you see these use cases being refined to smaller use cases that also capture the features of the system. So I hope you're getting the picture here. Basically, you use this top-down analysis of the value chain, or of interviewing or storyboard writing, whatever it might be, to get this big picture of the requirements for the system. Then you break up the requirements into packages that sort of where the requirements within a package sort of fit together. So for example, user withdraws money from ATM. All that functionality associated with a user withdrawing money sort of packaged into one thing that we're calling a use case. Okay, but use cases are also somewhat high level. Okay, they are not intended to describe the exact flows through the system, the exact interactions through the system, and not even just not to describe them, not even to capture the fact that these flows exist. So a further refinement of use cases are needed to capture these flows. So for example, user withdraws money or customer withdraws money from ATM can be broken down into customer withdraws money up to his limit from the ATM, customer withdraws money, a small amount of money from the ATM well within his limit, customer overdraws his limit, customer enters his password wrong. So there are all these things that can take place, interactions that can take place within a use case, which a use case doesn't capture, being at a higher level than all of those interactions. These sub-interactions, if you will, are captured by scenarios. So scenarios are also called flows. They're used to refine a use case. You can think of a scenario as one path through a use case. Typically, there is what is known as a happy path scenario, where the use case successfully executes, and usually there are many unhappy paths. So for example, with the ATM example again, user successfully withdraws money would be the happy path, but user enters a wrong password, or user tries to withdraw more money than he has in his account. All of those would be unhappy paths. The last thing about a scenario, or the last two things really about scenarios, is that when you describe a scenario, you start by describing the assumptions or the preconditions for the scenario. So, once again, the example of a user withdrawing cash, the scenario can begin with the user having approached the ATM and having inserted his card. It could begin there. Or it could begin where the user has inserted his card and entered his PIN number. All the things that have happened before the scenario are the assumptions. And then the result of the system after the scenario has completed is the outcome. So in the happy path scenario for user withdraws money from the ATM, the assumption is the assumption could be user has entered his card and his PIN number successfully, and the outcome would be that the user has withdrawn X amount of money from his account. And here is an example scenario from, once again, from the project that I've been talking about, the software system that's supposed to process foreclosures. The main use case is intake processor claims case from client system. You probably remember that use case from the use case diagram shown earlier. The primary scenario, or happy path, or the main flow as it's sometimes called, is the case being successfully claimed from the client system. But there could be unhappy paths or alternate scenarios as well. For example, the client system could have an invalid request. The situation here was that the countrywide home loans system could generate what looked like a foreclosure request, but because of some bug in their software, it was actually a request not for to process a foreclosure. It could have been even a bank loan request, somehow got into their system. Or it could be a request that's been posted as a duplicate. So that request shouldn't be claimed twice by the processing system or by the law firm, because that would mean that the processing would end up being done twice. And another alternate scenario would be that the case that was claimed did not have the right data, so the case was incorrectly launched. So within a use case, once again, there could be many scenarios, each describing one path through it. Typically, there's one primary scenario, also known as the happy path. In this case, it's the scenario where the case is successfully claimed. And then there could be alternate scenarios of various kinds. Most of the time, these alternate scenarios are error scenarios, but that doesn't have to be the case. So for example, if you think about the use case, user makes a deposit into an ATM. If that's the use case, scenarios could be user deposits cash, user deposits check, user deposits bank draft. There could be all these sub-scenarios within them. Incidentally, from this example, you probably realized that the granularity of use cases and scenarios is sort of up to you as the person capturing the requirements. You could capture each single scenario as a use case, but then you would lose a little bit of global perspective, because you wouldn't convey through your requirements document that a whole collection of features, if you will, or functionality that the system provided sort of belong together. So you might implement, when the designers build that system, they might implement each of their scenarios slightly differently, maybe use a different UI and so on. Whereas actually all of these scenarios should have had a single unified user interface, things like that. Just as the use case model captures the functional requirements of the system, which is what the system is supposed to do, the what of the system, non-functional requirements capture the how of the system. So for example, once again, take the situation of an ATM machine. A use case is user withdraws cash from the ATM. Okay, the non-functional requirement might be user is able to withdraw cash within 15 seconds, or a typical user is able to withdraw cash from an ATM within about 15 to 20 seconds of inserting the card. So this is not a functionality requirement, because the functionality requirement is simply user withdraws cash. It is what is known as a non-functional or design requirement, which puts a specification on how that functionality must be implemented. That is, it must be implemented in a way by which the user can withdraw cash within 15 to 20 seconds. Ultimately, both functional and non-functional requirements translate into behavior of the system, right? Because if the functional requirement is user withdraws cash, then there has to be behavior in the system that allows the user to withdraw the cash. And the non-functional requirement that says the user must be able to withdraw cash in 15 to 20 seconds it makes the system work fast enough so that it can deliver the cache within 15 to 20 seconds. So keep in mind that both kinds of requirements ultimately result in behavior of the system. The distinction, though, is that non-functional requirements drive the design of the system, not the analysis of the system. So when you're thinking about what the system is supposed to do, you can do that simply by looking at the functional requirements. It's when you try to design the system so that you can then build it, that's when you start considering non-functional requirements. And the reason to separate the two is to allow the software team, the software engineering team, the reason for separating the what from the how is to allow the software engineering team to sort of think, do the two functions, which is analysis, which is understanding the problem, and design, which is solving it, sort of separating them out so that they don't too quickly come to paint themselves into a corner with a particular solution when there are better ones around. Okay. Now, non-functional requirements, as you will see, can be categorized in various ways, and the typical ways are speed, performance, scalability, modifiability, usability, things like that. On this slide are some example non-functional requirements, and in three categories: performance, usability, and scalability. Now keep in mind one thing. Keep in mind the fact that an attempt has been made to quantify these non-functional requirements in the context of the system being built. That is, we're not simply saying things like the system must be of good performance, or the system must be usable, or the system must be scalable. We are quantifying exactly what performance, usability, scalability, etc. mean. This is very important. It's very important that the quantification of these non-functional requirements be in the context of the system. In other words, it's the quantification that is different from system to system. Okay, so for example, let's take usability. Okay, here we have said that the users must be able to use the system within 10 days. Why have we said within 10 days? Okay, remember the original rationale for building the system, that we'd be able to save about a month in training costs for each user. Well, 10 days is essentially a has been decided as the appropriate fraction that could be allowed for training users on the system. If it took longer than 10 days, the thinking was that maybe the system won't save as much money as we anticipated. That's where the requirement came from. It came from a business requirement. This usability requirement came from a business requirement. Secondly, you can see it's probably feasible to train a user on the system, even without having seen it or designed it or anything like that. You can probably see that it's a reasonable requirement that people learn how to use the system within 10 days. On the other hand, imagine a system that, for example, did robotic surgery. It certainly wouldn't be correct, a reasonable requirement that a surgeon learn how to operate this machine within 10 days, because in this particular case, robot surgery, you have a sense of robot surgery being extremely complex and dangerous and so on, and probably a surgeon would require weeks, if not months, of training before they could deal with all the the medical aspects of robotic surgery. So just keep this in mind, that non-functional requirements have to be quantified. Yeah, the quantification will be determined by the system that you're building. It has to be done in the context of the system that you're building. There are no standard quantifications of non-functional requirements, or at least not that many. By the way, here's an example of a standard quantification. The first one, the performance non-functional requirement, that says that the system must respond within 5 seconds. Well, that's true. That number came from the fact that studies have shown that users lose interest or get distracted or start doing other things if the response time of a system is greater than 5 seconds, of any system. So that requirement didn't really come from this particular system, but the others did. the usability requirement did, and the scalability requirement both came actually from the business requirements on the system, or the business case that the system was supposed to address. The next structured work product is a work product known as prioritized requirements. And actually, you might think that this belongs not so much in requirements, but really, it's really a project management work product. And you might be right. But the basic idea here is to take all the requirements, both functional as well as non-functional, and prioritize them and typically the prioritization is done on two axes. One is importance or business value. So in other words, adding this feature will will allow you to generate this much revenue from this product, that kind of thing. And urgency. And typically the urgency factor comes from whether other systems, other pieces of functionality depend upon it. So for example, a login use case or a login scenario doesn't really generate much business value because it's not a transaction that generates revenue. On the other hand, it has high urgency because other functions depend upon the login functionality being available. Okay. Now, when you prioritize requirements, you can prioritize them at a coarse granularity by use case and by non-functional requirement, or you could prioritize it in a finer granularity, which is by scenario within a use case. Even the non-functional requirements can be prioritized in a more granular manner. For example, you can have non-functional requirements attached with certain use cases that have to be implemented first and so on. So once again, the whole reason for prioritizing the requirements is to sort of give an order to the development process. And this in turn will drive two things. It'll drive what is known as an acceptance plan that we will visit next. And then of course, it'll drive all your project management work products because the prioritization will determine the order in which work will be done. And so that will determine the project schedule and your release plan and iteration plan and all those other things. And now finally, we come to the last work product in this list of structured work products. This work product is known as the acceptance plan, and it essentially closes the loop with respect to requirements. So, just as the storyboards and the use cases and the non-functional requirements and things like that sort of captured what the system was supposed to do, the acceptance plan is outlines the process for validating that the system actually performs as it was required to do. So if if everything else was a requirement, this one is a validation. It's a validation step as to whether the requirements. So both a verification and a validation step as to whether the requirements were A, implemented correctly, and B, were the right things to implement. Okay. An acceptance plan is also a contract closure document. So because it essentially commits the customer to a deterministic way of figuring out acceptance. So in other words, there is no, the idea is to not give the customer too much wiggle room in deciding whether the system was implemented according to specifications. It spells it out. So the customer is agreeing to saying that when the system is delivered to me, when the software is delivered to me, here's what I'm going to do in order to validate that the software met its requirements. Here's how I'm going to test it. And if you can verify, you as the developer can verify that the system meets these acceptance tests, then you can be satisfied that the system will be accepted by the customer. Okay. Now, a couple of things with respect to the acceptance plan. The acceptance plan is done jointly. It's not done just by the development team. This is because when people are actually asked about how they will test the system, the customers, I mean, they will be more precise in giving the requirements in the first place. And secondly, this is meant to be a collaborative effort. It's not meant to be an adversarial effort. And then typically in these acceptance plans, there is a time to fix clause. So, there is some wiggle room here in the sense that the customer might say, okay, you think you passed this test, and I agree that from your perspective, the way you understood it, the test passed. But I really meant this slightly different thing, and It doesn't seem to be that different from what was originally, what you thought it was. So could you please fix it? Or it could be a test that you genuinely missed because you missed some situation where your software would fail. So typically an acceptance plan includes time to fix clauses. We will fix any bugs reported within 30 days, things like that. And also an acceptance plan is less important for internal projects because it's after all the people from the same company doing this project. If something fails, somebody will fix it, et cetera, et cetera. One quick thing, I don't know how many of you ever bought a house or built a new house, especially. There is usually a walkthrough at the end, just before you sign the closing documents, where you go through the house and check everything off. And the idea is if you find anything wrong in that walkthrough, the builder will fix it for you within a specific amount of time. That's essentially what an acceptance plan is. Now here's an example acceptance plan, and I hope when reading through this, you immediately catch one thing, that all the items here are connected to your non-functional requirements, okay? So typically, there is less discussion about whether functional requirements have been met. So if you have a functional requirement, or a use case that says user withdraws money from ATM, well, hell, or heck rather, you test the system, you put your card in, put your PIN in, and if the system gives you money, well, it means that the functional requirements passed. So in a typical requirement, in a typical acceptance plan, the acceptance plan for the functional requirements is usually not spelled out in detail. So typically, there's simply a line that says all functional requirements in the release system must pass acceptance testing or something like that. Of course, if there's a very critical functional requirement, you might provide some more detail, but typically all that is said in an acceptance plan is all the things it was supposed to do, well, it should do it, okay? But when it comes to the non-functional requirements, okay, things aren't so simple. So for example, let's say that there was a performance requirement that said the system would respond in 5 seconds, okay? And the customer is supposed to test it. Well, does that mean that he tests it with nobody else on the system? Does that mean he tests it with 1,000 users concurrently trying to use the system? Does he test it with no cases in the database? Does he test it with 1 million cases in the database? All of those different things. So this, the quantification that I talked about that needs to take place from the non-functional requirements, a further quantification has to take place for the acceptance plan, because a deterministic test has to result from this process that the user or the customer can explicitly do, and the passing or failure of that test should be clear, and that constitutes the passing or failing of the acceptance plan. Okay, so you will see that in each of these cases, performance, usability, and scalability, we've taken the non-functional requirement and further quantified or refined it, made it deterministic so that it is clear how the test should be performed. So take a look at this. Okay, so with respect to performance, we say 5 concurrent users and 10,000 cases in the database. With respect to usability, we say test with the following 4 people. Now, my question that I would ask you is to think about for scalability, how you could take the quantified non-functional requirement, which are the first 2 lines there, user growth rate of 20 users per year and 3,000 new cases per year. How would you take, and 2 new company acquisitions per year, how would you take those and create deterministic tests, tests that you can actually do to pass or fail acceptance? When it comes to capturing requirements using agile processes, the trade-off is between the trade-off between structured and agile processes is you are trading off less documentation for more shared tacit knowledge. Whereas with structured processes, you are putting more into documentation and trusting less on the shared knowledge of the people on the team. So that's the basic principle. So the basic principle behind agile processes is to capture requirements capture just enough requirements and document them, and trust in the shared knowledge of the people working on the team to know what the complete requirement is. So keeping that in mind, let's look at the work products for agile requirements gathering. So when it comes to agile requirements capture, here are the work products. So the first work product, it might seem strange to call this a work product, is the customer himself or the customer herself. So the customers in agile requirements gathering is a first class work product, because the thinking is that customers are the true repositories of the requirements. Okay. However, there are some documents that are created to capture requirements work products. The first such document or the first such work product is a user story. Okay, so it's just so you'll see examples of user stories in the subsequent slide. But a user story is used to capture both functional and non-functional requirements. I hope you still remember what non-functional requirements are. The typical format or the accepted format for capturing a user story is shown here. As a role, I want a goal so that the following outcome takes place. And you'll see an example of that in the next slide. The third work product with respect to requirements capture in agile processes is the system test itself. This is a very novel and unique concept in agile processes. That is, the system test is both a validation of the system, but it's also a specification of the system. And the thinking is, if you can write a test for a piece of functionality correctly, then you probably have a very, very good understanding of what the functionality is supposed to be. And therefore, the test can serve as a requirement. Okay. Finally, agile processes are very, how shall I say it, welcoming in terms of accepting work products. So if there's a work product that you feel does make sense in an agile process, the agile advocates say, well, go ahead and use it. So pretty much any work product from a structured process can be an agile work product. But it's, the intent is to develop it in an agile way. So you don't spend time documenting it using a tool and printing pretty documents. You might just draw it on the whiteboard and photograph it and so on. Here's an example of a story that captures a functional requirement as an intake processor. So the role is intake processor. I evaluate a case. Okay. So I achieve a goal. Yeah. And here's the goal. I'm notified of a new case in the system, et cetera, et cetera. And finally, here's the outcome, so that I may accept it for processing or reject it. Hope you see how a typical user story is written. On the next slide, you'll see a user story for capturing a non-functional requirement. And here's an example of a non-functional requirement captured as a story, or rather, here are examples of non-functional requirements captured as stories. So the first one is a portability requirement. The second one is a compatibility or integratability requirement. The third one is an availability requirement, and the fourth one is a business requirement, all captured as stories.